My name is Jess, and welcome to Declare Victory with Class Macros. So, a little bit about me. I am an enthusiast of many things. The conference is almost over, but please feel free to come talk to me about any of these things. Andy is doing cartwheels in the hallway. I am going to call it soccer, Andy, soccer. We got that term from you. It's like association, like, football. I don't know. So the World Cup is coming up. Here we call it soccer. All right. So it took me a while to find all these things, but I feel like I really have found my communities. I moved to Rhode Island in 2015, and now I proudly declare that I'm a Rhode Islander. I don't know where I'm from. I'm from Rhode Island. And Ruby. I found Ruby in 2009. There was a code base that was written in Perl, and back then there was a script that you could apply to a Perl program, and it would convert the whole thing into Ruby, and that was the first Ruby code base that I ever worked on. I've been doing this for a while, and I love it. All right. I'm on Twitter, or I just signed up for Mastodon. I guess that's a thing, I guess. I don't know. You can tweet me there, but I never tweet. The only way to win is to not play. All right. I work for Splitwise. This is a shill session. Thank you, Splitwise. Thank you, RubyConf Mini, for granting me time up here to talk to you all. I hope to not waste it much talking about Splitwise. But Splitwise has a really cool mission. We try to help people with their financial relationships with their most important friends. So I'm sure everybody has had a chance to talk to somebody who knows something about Splitwise. If you didn't come to the game night last night or talk to Jen at the booth, you can come up and talk to one of us afterwards. There are, Jen, is this correct? 29 right now? Yes, I used the Slack directory. I think that's the only thing that's reliably up to date. 29 people, 8 back-end engineers, creating a Ruby project that has tens of millions of users around the world. It's like pretty dope. And you can visit splitwise.com/jobs. We're hiring. We'd love to have you join the team. Okay. All right, so now what we're actually here to talk about. Class macros. Well, before I launch into that, why don't we talk about what we're going to talk about? What are they? Seems reasonable. What can they do? How would I make one? All right, so let's jump in. What is a class macro? Every person who runs the Learn Ruby in 20 minutes sees a class macro. They are foundational to the language. They're so basic that people just get tossed right in on page 3. So what is it? You can go to the rubylang.org. There's a greeter class. It's got an instance variable. How do you access that instance variable? You can't access instance variables, right? So there's an adder reader that comes to the rescue. So we can call a method that will do something so that we can now access that instance method. So you can just say adder reader name. This is a class level method. So it is a class. And it is going to generate some code, and so it is a macro. So that is equivalent to class greeter define method name. And what is the body of that method? It's what's between the do and the end block at name. So now you can do this. So greeter will now respond to name. Great. Greeter, you can call name on it. It's Andy. I'm going to show you some tips and tricks along the way that, things that I do in IRB. People have all of their different patterns. I think it's really interesting to watch somebody else program just to see how they navigate the language and how they use IRB and their editors. So greeter has a set of instance methods. You can pass a Boolean to instance methods, and if you pass false, you get only instance methods defined on that class. Otherwise, by default or true, you'll get the entire inheritance chain. So say hi, say bye, name. It's right there. Greeter, you can, this is Ruby. There are no like first class functions in Ruby, oh no. But everything's an object, so you can actually get the reference to the method. So greeter has an instance method, it's called name, and so you can do stuff to it. It's a method object, and so you can call source location on it, and it'll say, when I'm running this in IRB, it'll say IRB line 19, and you can scroll back and be like, oh, where was that? Oh, add a reader name. Okay, so that's where it came from. I actually scoured the C code base to try to figure out how that actually works. If anybody knows, I would love to know more. I don't know where that comes from. Another thing that you can look at, and you've heard various talks talking about the ancestor chain, or what is the method dispatch or double dispatch, or all these sorts of things. This all comes into how Ruby does method dispatch. Anytime you include a module or you subclass something, you add to a class's ancestors or descendants. And so a greeter has a set of ancestors, and right now it is greeter, object, PP object mix-in, that comes from IRB, kernel, and basic object. And so that'll come into play later. I fell down this rabbit hole. Let's just take a look for a second. So I said, no, that was that. Is this true? Adder reader is equal to defined method. So adder reader is defined in C. I am not great at reading C, but like you can kind of piece by piece it together. ID for adder generates a symbol based on something. And so coming from the class and some of the arguments, it figures out what symbol that attribute should be the name, and then it assigns, it calls this Ruby adder method with it. So it passes in the class ID and true, false, true. So if you look at that, the class is indeed the value of class value is like a Ruby-ish object. And so it does a bunch of things, mostly involving visibility. And if it's a read, if read is true, which in this case it was, it's going to add a read method. So method type ivar, and then a bunch of other stuff. And if you look at define method, which is also the defined in C, it calls the exact same method, RB add method. Slightly different constants, but basically the same thing. All right, out of the rabbit hole. Other examples, any Panorama Ed folks? Okay, shout out Memowise. If you're gonna come to a talk and you know, why not have the organizer's gem in your conference talk? So Gemma, I think was working at Panorama Ed at the time she wrote this, and along with her co-author, who I heard was at the conference. I don't know if he's here, Jacob Evelyn. So Memowise is a gem that allows you to memoize something. They had a really interesting performance, like benchmark, so that like they benchmarked the hell out of it, and it's very useful. You should check it out. And so what we see here is Memowise, this method, is annotating something about slow value. And so if you read the documentation or dig into it, basically it's saying, well, let's see what happens. It sleeps for 2 seconds before returning, okay? So you call that slow value. Oop. returns immediately. The value is memoized. And so people use memoization all the time. Some of my developers have been like, oh, let's make a gem about memoization. And it's like, sure, you know, we could. It's been done. There's libraries, or it's not that bad. All right, finally, what is a class macro? A class macro is a class method, right? Everything's a method. So it's a class method that defines or modifies instance methods. So a macro in the old computer science nomenclature is something that's like small that expands to be bigger. That's like goes from micro to macro. Vim has macros. Excel has macros. The internet used to have macro worms, I guess, that infected Windows computers. In this context, it's a small method and it's going to make a bunch of other code. It's important to note, unlike Java, I don't know how many people are new to Ruby here, but like everything gets a run. So when the class is evaluated, that is a method and it runs at that point in time. And so if you make a class macro, you might have to add guard statements to it if you're running it in an environment like Rails will run methods several times during load. Maybe your database isn't ready yet. So if it's a database, if it involves a database, the database may not be there yet. And so just know that anytime you are like just evaluating your file, that code is going to run. Why do we do it? I think we just saw some examples, but we are declaring new behavior for the class. So we can add new instance methods, just like we saw with add or reader. Right? We can change the behavior of a class, just like, oh, actually this is a novel use case. I couldn't find an open source gem that had a good usage of this technique. We at Splitwise extracted like a library. We haven't released it as a gem. I'm not here to foist gems upon anybody. Publishable. Basically, anytime we have a bunch of objects that get saved, we want to notify other consumers about that. And so we wanted to do that via webhooks. And so that seems like the type of a library-ish kind of thing. And we really thought it might have a nice interface if we just could say something like, hey, this is publishable. How do you format it? Oh, we'll give it a presenter. What's our strategy? Oh, let's do it asynchronously. That's fine. If anybody wants to talk more about that, I'd be happy to talk about that too. So what does it do? Anytime you call create on a funds flow, it enqueues a webhook delivery job. And if you want to talk about funds flows and all the cool stuff that Splitwise is doing, again, I'm not here to shill. But. Okay, so finally, we can add new behavior to existing instance methods. I think this is the context that you're going to see class macros in most, especially with gems. We saw it here with memoize, where there's a method called slow value, but when we call slow value, we don't get the implementation that we see right in front of us. So it's doing something under the covers. Well, why don't we try to figure out what that is, and maybe we'll do it. Why do we do it? It's declarative. There's like a concept we just learned about functional programming in Ruby. There's also declarative programming in Ruby. Ruby's a great language for making DSLs. Something that can like look like a statement is really a method call, and so it's really nice looking if it just says publishable. And then you're like, oh, okay, yeah, I know what that means. And then you can just kind of move on with your day. You're not really concerning yourself with like when that code runs or why it ran or anything about it. It's just like you see it, it lets you know something about that class. It's interesting to think, this is really just a design choice. This is something that you're communicating to your fellow developers about the code that you're writing. And so oftentimes we do this as a courtesy to others or our future selves so that when we come back and we're reading the code, it's much easier to read and understand and reason about. All right. Hello, macro. given an example, real world example, I've extracted out a bunch of stuff, but we at Splitwise people can add expenses in lots of different currencies. Sometimes they are not in their native currency, and they want to translate those expenses back to their home currency so they can settle up or pay somebody on Venmo, and you can't pay somebody in kroner on Venmo, last I checked. So this is a pretty basic script. I signed up for, you can go to Open Exchange Rates and sign up for an API key. It's pretty cool. You can call all, you'll get all the rates, and then it's like if you want to do some conversion, you're great. So any issues with this? Other than, I'm sorry, Canadians, I don't make US monetary policy. I actually looked at the graph, it's not that bad. But it's not great. So the free service for exchange rate service, you only get 1,000 API calls a month. And so at this rate, I'm going to be out of API calls. The solution, of course, is throw money at the problem. I like this idea. I like this idea. I actually don't know if we pay for that subscription. Caching. All right. So let's cache it. So we're going to take this class and we are going to just wrap, given the fact that we have some cache somewhere. I'm using global variables here just so for brevity of the slide, but most caches will have a method on it called fetch, and you pass it a block. And if it's there, it will retrieve it out of the cache, and if it's not there, it'll execute the block, it'll return that value to you, and it'll store that in the cache. It's really a nice interface. And you need to have some key there because it's otherwise what are you fetching? So I just named it after the method. So all. Okay. Is this better? Whew, looks better. Let's double check. Maybe it's like Julia's DNS caches. Nope, or we're still good. Okay, good. Okay, finally, when we're writing a class macro, we have to ask ourselves, what do we want the interface to be? So we saw Memowise. Memowise used a prepend. It overwrote the existing method. These are all choices that you can make. You can define new methods always. If you want to really intercept the call so it's always called, you can do that. If you want to provide a backdoor to get to the original method, you can do that. These are all just design choices. None of them are bad. It just really comes down to your use case and what you want to do. Okay, so if we have, this is our cached implementation, but I want to extract that into a class macro. What do I want the API to look like? Cacheable. It's like I'm annotating there's a method somewhere called all, and it's going to be cached. Maybe someday I'm going to add some new options to it, expiration. There's something called a race condition TTL, so you don't do a thundering herd on it. And I'm old-fashioned. I like to include things. I think most people are used to seeing include. Some people don't mind using extend or prepend. I don't know. I just, my spidey senses start to tingle when I see something, and my brain gets stuck on it, and I can't keep moving. If I see include, I don't know. I'm in my happy place. Okay. So how do we get there? These are the questions that you have to ask yourself as you're going through the process of writing a class macro. And so, what needs to exist? How do we create them? And how do we include them? Ooh, sorry. Okay. I'm going to try to do this in 10 minutes. What needs to exist? Okay. I need an all method that adds caching. Okay? So I have all, and I want like all with caching, and that calls all. Okay. What else? I need an all without caching, because that's what I've decided to do. I want to have the ability to call it without that. And so you see that here. I have an all and an all without caching. I can't have two methods called all. I'm going to have a cacheable module. I need something to include somewhere. So that is the cacheable class method. Oh, I got my, oh, I don't know what that is. I have the cacheable class method, and so cacheable.all. And then finally, I need a cacheable module that I can include somewhere. And so that's right there. So this is basically what I'm aiming for. Okay, that's what needs to exist. Okay, how do we create it? All right. So piece by piece, we need an all instance method, an all without instance method, a cacheable class method, and a cacheable module. Okay. All right, one by one. All instance method. So I had set up an all method and an all without caching. I'm going to move that aside for a moment because I don't want to have the cache code in my original class. So how am I going to get it, like the behavior there? I'm going to wrap a module around it. Okay. Well, now I need one more thing. I need a method interceptor module. I need a place to put these instance methods that I'm creating. And so now I have that. I can have include my method interceptor, and all can be there, and it can call all without caching, and that's in my original method. Great. But I want the name in my original method to still be all. Okay? Easy? Okay, so in my method interceptor, I'm just going to have all call all. You get circular dependencies, stack trace too deep. How would a method called all call its parent class with a method called all? Luckily, we have a mechanism to do that. Super. We can just call super. It just goes right up the stack. It'll use the same arguments. I've eliminated all arguments from this code just for ease, but it's great. The interesting thing, and this talks to what I alluded to way back when I was talking about ancestors, is now I need all to be in the ancestors, the method interceptor. I need that to be in the ancestors before the actual class. And in Ruby 2, once upon a time we only had include, so we had to do a bunch of weird stuff involving alias method, and it was bad. But now we have prepend, and so we don't have to do that anymore. And so if we prepend the method interceptor, it's just like include, but instead of in the ancestors it coming after the class, it comes before the class. So anytime you call exchange rate service all, you're going to get the one in the method interceptor. We did it. Okay, now let's have all without caching. All without caching needs to call the original all method. I don't know where that slide came from. Like I said, I'm not a Keynote expert. No! I lost it. I lost the slide. Okay, so we're going to talk about it. So all without caching needs to call the method interceptors, the exchange rate services version of all. And so it needs the ability to call alls in method interceptors super method. And there's a way to do this, and I would write the code up here if I could. And that is by implementing all without caching. There's another bit of metaprogramming you can use, just like we saw before, where we can grab the method object. So we call method all. So we have that method interceptors all. And then you can actually get its super method. And so you can just call all method all super method. And now you have that super method, and you can call it. All right. Now we want to do something interesting, and maybe the slides will come up here shortly. We need to get rid of all, because we need to make something generic, and so we need to just make it generic. And so now we're just going to use with caching and without caching. And so, there's my method all. My super method, it's back. Okay. So in order to do that, we're going to replace all with define method. So instead of def, you can use define method, and instead of a symbol, you can just pass in whatever you want, and so you get method name. So we're going to do this for both. So now I have a method name, all, and a method name without caching, all without caching. And I have this one here, all without caching, and I'm not going to go through how to get rid of that, but we'll get there. Okay. So now I have the method name. I can just call method on the method name, get its super method. And so method in method interceptor calls all without caching. All without caching refers back to where it came from, but knows that it wants to call its super method, and that's how it gets out. Oh, I did fix it. Great. All right, so finally, we need to define the method interceptors. And so the method interceptor, you can call module.new, you can define the method, the module, and open it up later on. There's a couple different ways you can do that. Okay, so how do we create them? Now we need, how do we create the cacheable class method and the cacheable module? These are a little bit more straightforward. We can just define a module, define a method. What's in it? I'm not going to worry about it yet. There is one thing, though. If you look at the interface that we wanted cacheable to be a class method. And in doing so, we need, if we just included cacheable and define cacheable in the cacheable module, it would be an instance method. So we're going to define this as, put it in a separate module, and at a certain point, maybe we'll just include that in the class. Okay, home stretch. How do we include them? So we said include cacheable, that's our desired interface, needs to basically do extend those class methods. So we need to load those onto the class itself, so that they're class methods. And I want to prepend the method interceptor. That's where the instance methods are coming from. How did we do this? Hook methods. This is a final little bit. So module defines a bunch of different hook methods. They are run by Ruby itself when various things happen, and then you can override them and you can get custom behavior on your classes when these things happen, like when your module is included or extended or inherited, method added, method removed, method undefined, all kinds of fun stuff. Okay, so how do we include our instance methods? So we have our method interceptor. So we are going to include cacheable. So in cacheable, we're going to open up this hook method, included, and then we have our method interceptor. And so all we have to do is prepend method interceptor onto the class handed to us by the included hook method. Likewise, the exchange rate service includes cacheable. So when cacheable, we're going to, same thing, open up the included hook method. And we have this class methods module that we defined earlier. And so we're just going to base, this time we're going to extend with class methods. Extend is just basically like include, except it includes it at the class level. Okay, let's put it all together. Given our class with our nice API of include cacheable, cacheable all, we're going to have a module. It needs the hook method. That hook method needs to prepend our module with our instance methods. It needs to extend with the module with our class methods. We have a macro, and cacheable is going to be passed some symbol, all in this case. So when we receive all, that is the original method name. We wanted a without cache method name, so all without cache. And now we're going to open up our method interceptor and define two new methods on it. And we can do this every time we call cacheable. So we're going to open that module up, define two new methods on it, all and all without cache. It's the worst transition ever. Okay, so in the body of the all method, this is where we have our caching. We saw this before. So we have this cache, and all we're going to do is we're going to call the without cache method name. Okay? And finally, our without cache method name is going to call back to the other method, except call its super method to get the parent behavior. All right. That's it. Class macros. What are they? They are a method that is included in your class that changes the behavior of your class, usually by declaring a bunch of instance variables or other things. What can they do? Magic. They're really cool. They can show respect to your fellow developers and your future self by making declarative constructs so that you don't have to think so hard every time you read your code. How do I make one? Download my slides. I don't know. I will admit, if you remember one thing from the slide, I will admit I don't remember all the time how to make a class macro. If you remember one thing from this talk, callback, please don't remember that Splitwise is amazing and that we are hiring. That's not what we're here to talk about. It's not even how to make a class macro. That is like what ostensibly you are sitting in this room for, or you work with me, and so, or for me. So you have to be here. Every time we spin up a new thing that is a class macro, I will refer to this gem that one of our former engineers open sourced. It's called Cacheable. It does this exact same thing, and it has a bunch of other metaprogramming to handle all the edge cases. Download it and repurpose it to do whatever it is that you need to do. It's a good gem, but nobody uses it. It's fine. If you remember one thing, it's that we, the Ruby community, the one that I found in 2009, the one that you are all part of, are amazing. And I've had such a blast here for the past 3 days, talking to you all. It was so amazing that Gemma spun up this conference from nothing and that you all came. And so for that, I thank you.